It's Friday in the AWS Developers Podcast. Today we're talking about Twilio and Amazon Verified Permission. We'll explain all that in a moment. Good morning, good Friday, good afternoon. Every Friday in all good podcast applications on Deezer, Spotify, Apple, YouTube, and many others on the web as well. The AWS Developers Podcast, all things that matters for cloud developers, for cloud builders. And today I have not one, but two guests. I have Peter Lavelle, principal software engineer at Twilio, and on the AWS side I have Edwardson, your security solution architect. Thank you, gentlemen, for being here. We are going to talk about permission, access rights, custom application, how it fits together, why, how, but maybe start with the beginning. What is Twilio?
Thank you. Yeah, thanks so much for having me on today. I'm super excited to be here. For those unfamiliar with Twilio, at our core, we are a communications platform as a service. So we offer a set of tools that allow developers to build communication workflows into their application, leveraging channels like voice, text, chat, or video or email.
I remember I did a cool demo with Twilio a couple of years ago. I was working for Alexa, and I created an Alexa skill that was able to initiate a phone call to my cell phone using your API. I guess it was a free API at the time, at least for the demo purposes. And I managed to initiate phone call. That was super impressive to say, "Hey Alexa, call me." It was
yeah. That was my first experience with Twilio too. Way before I joined, was using their really easy to understand, developer-friendly APIs to send some text messages, with some applications I was developing too. So I grew to love their APIs, and then eventually I joined the company.
But I guess your customers are not building just demo. What is a typical application built by your customer? Are we talking about something at the scale of call centers or applications like that?
Yeah, I think, our core set of tools are so versatile that you see, many different types of use cases. We have, use cases from MFA verification over SMS to, like you said, all the way to, full-blown contact centers or digital engagement centers that we offer as applications on top of those core tools. So the particular product that I work on is actually one of those applications that is built upon those core tools. It's named Twilio Flex. And Twilio Flex is, as I mentioned, a digital engagement center that allows companies really to meet their needs of the customers at every step of their life cycle, from like sales to pre-sales to support. And as you asked, a simple example of a company's use of Flex could be to create a support contact center where a customer can call in and initiate a support request, whether that's, again, through chat, through text, through web chat, through email, or really any preferred channel. Flex will route that request to an available agent, and that agent has the skills to handle that interaction to help the customer with their request. So the applications that I work on are built on top of those core tools, and really deliver delightful experiences to our customers.
So when I'm a customer of a bank or an airlines, and I go to their website and I say I need help, and then I can choose call me, start a chat, or send me a text message. It might be the Twilio Flex or the low-level Twilio API that company is using to call me back and to put me in touch with an agent.
Exactly. You got it. Yeah. And we handle all those type of channels, and we route them in a really easy way for the agents to handle. And we provide a bunch of tooling for all roles that interact with our application, but especially agents and supervisors, to be able to make those experiences more personalized for their customers, and at the end of the day, much more delightful.
So I said at the beginning in the introduction that we are going to talk about permissions and fine-grained access permissions to these tools. So what was the challenge you were trying to solve? What was the business requirement? Where did you start from?
Sure. I think to answer that, I need to just step back a little bit into the journey of Twilio Flex, which is the application I work on, as I mentioned. Mm-hmm. So when Twilio Flex launched in 2019, the authorization needs of the system, of course, were fairly basic at that time. And what we leveraged was Twilio's resource-based permission model. Now, it's been 5 years since then, going on 6 years. And, with time, Flex has evolved into a really feature-rich, programmable digital engagement center. And we face the challenge really of implementing a sophisticated authorization model to accommodate complex access control requirements that were really we weren't able to meet them through that resource-based permission model that I mentioned initially. So the challenge to us was to introduce a new system that kind of augmented our resource-based permission system and would address the growing need for granular permissions based on roles, relationships, or other contextual factors that the resource-based permission model that we had existing really could not handle.
Yeah, typically an application relies first on authentication. It's telling who is the user of the application. And then there is like a second layer, which is authorization, saying, hey, based on who I am and the role that I am, and I don't know, the API or the screen I want to access to, do I have permissions to do that? So if I am Tom's manager, maybe I can see the history of the calls for Tom today. But if I am someone else's manager, I cannot see the history. That's the type of problem you were trying to solve. But of course, at such a scale that the traditional role-based access control was not enough. Did I understand correctly?
Yeah, that's right. It was not enough. I think, initially what we had is a really basic way to, mint a token, and that token gave you access to a set of APIs based on your role. So kind of maybe like more traditional role-based access control. But once you have access to those APIs, how do they then enforce more granular permissions based on their use case of that API? And that's where we really needed a solution to solve that problem.
Yeah, what if there are some sub-part of the data that are returned by the API I cannot have access to, but I have access to the higher level API? So should you split the API into multiple ones? So
right.
It might become a nightmare. And then you were searching for solutions on the market. What type of solution, without naming them necessarily, but what type of solution can address your specific needs? Because you're not the only company having such a requirement for fine-grained, granular authorization to API data.
Yeah. So stepping back again to the beginning of the project, of course, while AWS is a partner and a preferred vendor for Twilio for the majority of our solutions, the first choice that we really wanted to make was what type of authorization system we wanted to implement. So along with Amazon Verified Permissions and the policy-based authorization system that it offers. Around this time or a couple of years before that, Google came out with a paper called Google Zanzibar, a white paper. And we saw a lot of companies popping up with these kind of graph-based authorization models as well. So our choice there, as we were evaluating the use cases, was do we go with one of these graph-based authorization models, or do we go with the policy-based authorization model? And that was really the first choice that we had to make before moving forward.
Can you maybe briefly explain what is a graph-based authorization? I guess everybody that listens is used to RBAC, role-based access control, because that's what the industry uses since like 40 years or more. Graph is a bit new, at least it's new to me, and policy-based. So what are the main difference there?
Yeah, good question. And, and I think, for a lot of use cases, there's definitely some overlap there, because I feel like policy-based can really do a lot of things that graph-based can do, not in the same way, of course, but it's all achievable. But, when we were initially going through our evaluation, we had a set of use cases that came from our product team. And actually, these graph-based systems seemed like a natural fit. and I'll explain why. So with these systems, what you do is you define an authorization model with the types of objects in your system. So similar to kind of what you would do with a policy-based model, you set up your schema, and then you set up kind of how the objects in the system relate to each other. And then, what happens with these graph-based systems, once you have that model set up, is that application systems push authorization relationship data based on that model to a central data store. So if we go back and if we step back and we take that use case that you mentioned where a supervisor manages a set of agents, that relationship of the supervisor being a manager over another particular user is the data that's necessary to push to the central authorization system. So that's the kind of fundamental basis of graph-based systems is you push all the graph-based relationships into a central data store. And then finally, when you need to make these authorization checks, you do the checks against those relationships that have been established in that central authorization store. So as I mentioned, as a manager gets assigned to a particular user, what happens is that system will push that data to the graph-based central authorization data store, and then every time that changes, the application is pushing the changes up to that central data store. So it acts like it's almost a duplicate of your data in the graph-based store. And then what happens is if another application needs to ask about, hey, can this user say update the skills of this other user? Then it's actually a pretty simple check to ask that question because your data is already stored in the central data store, and the authorization systems can then traverse that graph, determine if this user is indeed a manager of the other user, and can execute this permission, and it returns an authorization result, either allowing it.
When you say the data are stored in a central data store, we talk about the data about the organization itself, so the relationship between the people and the permission, or are you also referring to the business data?
So it really could be everything. So,
okay.
Whatever you need to make your authorization decisions based upon, you really need to push that to the central data store because that's where those decisions are made. So if you have authorization decisions that are based on something outside of those relationships that I'm talking about, all that data needs to be pushed to the central store.
Modeled and pushed to the central data store.
Right.
So that was one solution that you look at, but you also look at a policy-based system. What are the main differences there?
When we looked at the graph-based authorization system, it initially seemed kind of like a perfect fit for our use cases. We had pretty simple set of requirements from product. All of those were relationship-based decisions that we needed to make, and we said, "Oh, this is a perfect fit." Let's go ahead and explore this, and we did some presentations internally, and that all seemed great. But obviously, we're on the AWS podcast today, so we obviously didn't go with the graph-based solution, right? So, like you said, the question becomes, I think, how is policy-based different? Which I'll get into, and why did we decide to make that switch? I think that the short answer for that is that we really took a hard look at some of our requirements from our customers, and it actually wasn't. Graph-based systems actually weren't a perfect fit for the promises that we make to our customers. And I'll explain kind of
which one, for example.
Yeah, so as we've continued to evolve Flex over the years, as I mentioned, we have always had resiliency as a top priority, and we really have to make a lot of tough decisions. For anyone that works on these types of systems at scale, you have to make really hard decisions that sometimes slow your feature development to make sure that you maintain kind of exceptional uptime and resiliency for your customers, right? So as a contact center, of course, if you have trouble, booking a flight through an airline and you call in for support, the worst thing that can happen is that the whole support system is then down, right? And that's just really a terrible customer experience. So, resiliency and uptime are, top priorities for us. So, if you can imagine going back to that, airline use case, we're trying to avoid that really terrible customer experience. So, as I sat in more of these architecture meetings and I heard about our future plans to really bolster the system to be super resilient, it became pretty clear that we needed more flexibility in our solution to both be resilient and to reduce the blast radius of any outage. So that's where we made the pivot. So that's where, these policy-based authorization systems really started to pique our interest. Yeah, good question. So we found that the policy-based authorization could solve really the same needs as graph-based authorization, but there are some really clear advantages for us. I think while they both share the same, and I'm going to use some policy-based specific language here, but we found that both share really the same policy and enforcement points in our application, right? So who needs to make that decision doesn't change. It's the system that has to make that more granular decision before allowing a certain feature or permission. But then the flexibility that we really found was really around the policy information points, and the policy decision points of these systems were very important to us. And I can talk a little bit more about the policy information points and what those are for us, and the policy decision points and what those become for us as well.
My understanding, if I remember correctly, is that the policy enforcement point is the point in your application where you will actually verify a policy, and the policy decision point is the point in the service where we compare the data that are provided by your application, the policies, and the system say yes, that person can go through or not go through. At super high level, maybe Edward will have a more formal definition in a minute as well. So with that history and looking at different systems and your requirement for extremely high availability because of the use case you're supporting for your customer, at the end you made a choice to go for a policy-based decision where the policy decision point can scale as well and can be replicated. When there is no central point of failure for the policy decision point. Did I understand correctly? Mm-hmm.
That is correct. And also there is an essential point for the policy information point. So it's the two of those that were really differentiators for us.
The policy information point is where the policies are stored. It's a data store for the policy. That's correct, or not? No, I see from your face. It's
well, yeah. I think more of that as to where do you get the context to make an authorization decision?
Okay.
Right.
That's a really vocabulary very specific to policies.
Right, because these were really the factors that made us pivot. So, first with policy-based systems, we didn't need to centralize and duplicate all of our authorization data. So I mentioned with graph-based systems, as those relationships change, these systems constantly need to push those updated relationships to the central data store, which uses that to make decisions, right? So the difference there is with policy-based authorization, that metadata, such as the relationship between two users, can be passed along with the authorization request itself, right? So it doesn't have to be pre-populated in the central data store. It can be passed at runtime with the authorization decision. So if an application needs to make a decision, it doesn't necessarily need to rely on that centralized data store, but can instead use the data that it has in its own data store and pass that along to make that check. So what that removed for us was that really single point of failure to say if this if this central data store, this graph model, this graph database goes down, what happens to us, right? And the answer in a policy-based system is you do not need to rely on the central data store. If you have all the information that your policy needs to make a decision, you can simply pass that in runtime, and you don't have to worry about pre-populating that central data store.
And the application collects some of the context and pass the context to the policy decision point as well. So
right, exactly, which is particularly great if the microservice itself has the data in their store. Right, there's really no need for it to be constantly syncing. It could just read it when it needs it, and it could send it to make that request.
Yeah, it simplifies also the syncing with an identity system. If you have like a large Active Directory or, an LDAP, you don't need to import and keep the policy system in sync with the identity system.
Exactly, which is a big advantage for us. While we chose to use the managed service in AVP to make our authorization checks initially, I did talk about kind of how the policy decision points can change in a policy-based system, right? So one of the great things with AVP and, with kind of CEDAR-based policies is that it is possible to make local decisions with policy decision points as well. So again, like I mentioned, if one of our domains and one of the microservices of those domains has both the data and the policies that it needs locally, it can use a tool like the AVP local agent, which is on GitHub, to make that decision, whether the local agent is running a sidecar or in a separate standalone service in the domain. With these types of strategies, there's actually no need to make that central call, the direct call to AVP.
Yeah, so there is no central system where all the policy decisions are taken. Some of these decisions can be moved back to the microservice themselves, as long as they have the context data and the policy up to date. Of course, at some point they will need to communicate with the central system to retrieve the policies. But if temporarily the system is done, the permission system is done, local decision can still be applied. Did I follow you? I'm just rephrasing to be sure I follow you correctly.
That is exactly correct. And I think the great part of the AVP local agent too is that it handles the synchronization of the policies down to the local agent, and all of that comes out of the box. So that's really just super cool. And then again, like I said, you just need to pass the right contextual information to that local agent to make the decision.
So, before going deeper into the benefits of AVP, maybe what is AVP for the listeners? And I'm not the right person to explain that. I'm not an expert of that service, and that's why I asked Edward to join the podcast as well. Edward, thank you for being here. So you're working for AWS, you're a security solution architect. What is AVP that Peter is talking about? And what you mentioned something else, Peter. What is CEDAR as well? But let's start with AVP.
Sure. Thanks, Seth. Thanks for having me. So AVP, or Amazon Verified Permission, is really our fine-grained authorization as a service. As Peter mentioned, the permission management has always been a very critical part for the application. And then with Verified Permission, where the end goal is we want to decouple the authorization logic from your business logic. So as the developers, we can focus on...
We don't want developers to create code with if user equal blah blah, then do something. No, we want to delegate that to an external system.
Yeah, exactly. And then that has been the historical ways of managing permissions in your application, writing a bunch of if-else statements in there. Right? It's very hard to understand for someone that is not directly working on the product if that product needs to be maintained throughout the life cycle. The new joiners or other people who didn't write a particular if-else statement logic need to first read what it is, and then they understand it. They have to make improvements or iterations on top of that, right? So AVP will help customers to actualize their authorization logic. And then how we do that is by using the policy-based authorization system. And then the core of this whole thing is called CEDAR policy language. CEDAR, the whole concept of CEDAR is very similar to how IAM policy is written. So for all our AWS developers listeners, if you have written IAM policies, I'm sure you have, the construct will look very similar. It has the three parts, the effect, similar to IAM policies. You have the allow, deny. Cedar will start with a permit and forbid. And then you can continue with your scope, your principal, action, resources, what you want to control, how your principal can do whatever actions toward what resources. And then it can also create some constraints around the policy scope in condition. It has a when or unless statement that you can add additional claims or even add an additional tenant identifier for some of the B2B customers that we work with. And then once you have written the Cedar policy, you have the options to store it in a policy store. In the central policy store is one part of the APIs that AVP offers. And then the other part of the API that AVP offers is a authorization engine. You can make the calls when users come to your application. So user wants to do something, you make that call to Cedar's authorization engine, and then they will return with a binary allow versus deny decision. And then for your application, you just need to enforce that decision as the policy enforcement point.
So there are two roles. One is the administrator of the system. I'm writing the policies and I'm storing the policies in the service. And then there is the developer that has an API. In my application, I want to know if that user is authorized to do this action. So I will take some kind of context, who is the user, his role or whatever, the name of the action, and I will call an API to verify, to ask the system to verify if the user is authorized to perform that action. And that system will read the CEDA policies and will return me yes or no, basically. And then it's up to me, the developer in my code, to enforce that decision, yes or no. At high level, did I understand correctly?
That's 100% correct.
And you told me there are some additional perks because most of the verification points happens at the API. So on AWS, when you use the API gateway, we can enforce the policy verification, or we can put an agent or something in the API gateway to verify permissions there as well.
Yeah. So this is actually a new feature in verified permissions, and it's called the Quick Start experience. We're a quick start wizard. So what it does is a lot of customers felt, oh, is this a new service that I have to adopt? I don't want to really poke into the different pieces and understand how to write a policy to get started in the proof of concepts environment. What this quick start experience will offer you is especially for customers that are running on API gateway. AVP Quick Start can look at your API configurations, all your methods, and then all your API paths. For example, you have a get/user path. And then it can also collect your OIDC identity parameters spec. So if you're using Cognito, that comes very natively, you just pull the user group and user attributes information from Cognito. Or if you have a third-party OIDC parameters, AVPs, you can provide that information to AVP, and then it provides you a point-and-click user environment or user interface to allow you to assign access to different groups or to different permissions. So you have administrator groups can do XYZ actions, check those boxes. Your normal users can do ABC actions, check those boxes. The Quick Start wizards will then generate a Cedar policy and then the schema for you based on the actions you have chosen. Automatically create you a Lambda authorizer and attach that to your API gateway. So for your proof of concept or for your applications that are actually running those, it becomes very instant. You have this authorization model already built out for your application.
And the Lambda authorizer is actually where the code is going to be to call AVP and to verify the policies and tell the API gateway yes or no, basically. Okay,
yeah, so
that's super cool because I can start super quickly without programming a lot, just by pointing a resource that already exists, the API gateway, and that's pretty much it. What about CEDAR? You mentioned, both of you mentioned CEDAR. So it's a policy language. It's a language that we are using to define, that the administrator is using to define a policy.
Yeah, so CEDAR is the one, as you mentioned, is the policy language. And then one thing I actually forgot to mention is AWS also chose to open source CEDAR. So the CEDAR policy specification, you can find all that on cedarpolicy.com. The other part that got open source is the SDK for rule evaluation engine. And then this is something, if you want to build CEDAR, we have some partners already done it. They wanted to customize the CEDAR authorization piece. They can use the SDK for that. The Amazon Verified Permission is actually the hosted version of CEDAR that AWS hosts and then provides to our customers. And then the local agent or AVP local agent feature that Peter mentioned actually use the policy store that AVP hosted, but run authorization or run rule evaluation locally based on the open source spec.
So it's possible to use the same technology, CEDAR, and the verification agent without using the service from AWS, just using the open source pieces. And I guess there is a community around that is growing, and more vendors are adopting CEDAR, or CEDAR, I should say. So the advantage for the customer is that they can learn one policy language and reuse it at different places. That's the idea of an open source policy decision. Thank you, Edward. Very clear. Based on that information, back to Peter. You, Twilio, decide to use AVP and CEDAR, and you start the implementation of that project. How did it went? And what were the challenge that you had while building? How much time it took? What was the challenge you had to build that solution?
I think it went really well overall. Of course, we had wonderful support from the AVP and AWS teams, which was always great. I think the real challenges sometimes with policy-based systems is they aren't necessarily as easy to explain across the company, or and in some ways it makes it a little bit challenging to just to sell it to different teams, to say this is the direction that we're going in. When we actually got to implementation, I found it to be very straightforward. I think some of the challenges when compared to graph-based systems are that graph-based systems are easy to understand and implement. Policy-based systems, like Edward mentioned, you have to go and author your own policies. So that naturally lends itself to an additional layer of governance over your policies, because you really need to make sure that these authorization systems are error-free, right? And I think that's easier to achieve in graph-based systems in a way, because you can't, you don't have all the flexibility of policies. But we found the flexibility of policies to be a huge advantage for us as well. So, you kind of need to make those trade-offs a little bit, but with policy-based systems, you do need to go and, teach your different teams how to author policies and then do checks against those policies, where graph-based systems are more, just push your relationship data up to a central data store and then make a check against that relationship.
So you have to teach the concept of policies-based access to the business and let the business admin of the application manage or create the CEDAR policy by themselves. So they have to learn that, the business people, I mean.
That's right. And then, as an engineering team, you need to go and make sure that to achieve error-free, you have to make sure the policies don't conflict, like you aren't granting access to more that you shouldn't be. And that is a little bit more challenging with policy-based software.
I think I read somewhere there is a way to mathematically prove that a set of policies is complete and correct. If we manage to express the specification in one language and the CEDAR policy in another, there is a way to automatically verify that. Am I correct, or am I mistaken with another systems?
Absolutely. And then it's something that CEDAR actually work with automated reasoning in AWS. So there's a whole teams behind AWS that is spending a lot of time on automated reasoning using mathematically proved way to making sure the authorization language that we provide to our customers can be trustworthy and then is always correct. And then some part of the proofing that they have done are if you are written a forbid statement in Cedar, it always overrides a permit. Just give an example in policy evaluation hierarchies. And then your permits are actually only granted by the principal towards that action, using that actions towards that resources that are written in the policy. It's not individuals, principals are not gaining additional actions or additional permissions by error or by default or by errors in policy evaluation process. There's a whole papers on that and how Cedar work with automated reasonings to prove always be correct. I encourage our listeners to give it a read.
All the notes, all the links are in the notes of this podcast. So you scroll down on your webpage or in the podcast application and you will have all the links for further reading. So that's the type of things you had to learn. Your team had to learn to the business people, Peter. It's how to write CDR policy, how to be complete, how to ensure they cover all the possible cases.
Right, exactly, right. So we have a team that helps author those policies. Again, making sure that because typically these other teams aren't familiar with authoring policies all the time. So we'll help them with the onboarding process, make sure that the policy makes sense in the context of the use case, and then help them shape the data that they need to send along with the authorization request to make sure that it can successfully evaluate the policy.
How do you define as a team the metadata catalog? What are the metadata that the policymakers can use to write the policies, or that the developer can collect and send to the policy decision point?
Yeah, good question. So I think earlier I mentioned that one of the drawbacks to a graph-based authorization system is that you really do need to have all of your authorization data duplicated and centralized in a store to make those decisions. What we introduced with our implementation of policy-based system was an optional way to store that metadata on the side, right? So, like I said, when you're making these authorization decisions, you need to post all the contextual data to make that decision. But with our system, you don't necessarily need to do that in the request that you send to the authorization server. The authorization server can then go and look up additional metadata that's been persisted and pass that along to AVP as well. So we kind of took some of the nice parts of the graph-based authorization system, which is an ability to store metadata in a central place if it's not available in the system that has it at the policy enforcement point, right? So if other systems, if it makes more sense to them to periodically update a central data store, then they can also have that option to do it. Now, it all really depends on the use case, right? Because our top priority is resiliency and uptime. So we want to make sure that by leveraging that central data store that we've introduced, it doesn't introduce yet another single point of failure into the system, right? So what's great about that, though, when compared to graph-based authorization systems, is that it's optional. If you have all the data, send it along with your authorization requests. It'll never need to talk to the central data store. If you want to use the central data store and it makes sense with your use case, then you can do that as well. And that's where we find policy-based systems to give a lot more flexibility with those decisions.
Yeah, you have the two options, either a local evaluation, either a central evaluation when the system is available. Just to be real and concrete with metadata, what are we talking about? The first one I have in mind, of course, is the username, groups, maybe the email address, IP address, and things like that. But what else is a metadata for your app? I realize it's really business-specific and depends on your application as well.
Yeah.
But just to get a sense of what we are talking about here.
I should probably use the AVP Cedar language and call it an entity store, because that's really what it is an entity store. And what it stores today is really kind of going back to the graph-based model. It stores some relationships between data in our systems, so that we can read those relationships while we're doing the authorization checks. And it also stores some metadata about kind of the state of, whether it's the state of some of the features in our system, or the state of a particular user. You can really put anything you need to model your policy into this central metadata store, and that's the way it's built, to be super flexible. And then as we're reading the authorization decisions, we just need to make one query. We get back all the contextual data related to that user, again, optionally, and we send that forward to AVP. So, it's really the way that we model this is it can really store anything, and that's why I call it a metadata store. But today it's really more used as an entity store, which kind of more aligns with the language of AVP.
Yeah, naively, I was thinking that it's just the JWT token that has groups and user information that we pass to the policy engine, but actually it's much more than that. And you have to maintain and to store these relation between the data.
Right. And the way that authorization works, a lot of times the downstream services have access to that JWT, so they can actually read the data out of that that's necessary for their policy evaluation and send it as part of the request, right? So especially with the metadata from a JWT, you want to make sure that that is not stale, right? So you want the downstream services that's consuming that JWT to be able to extract the necessary metadata and send it to us, instead of us having to try to persist that JWT data, which could end up stale, and then of course, it could introduce some errors into our system.
And on top of the benefits of availability, I guess there is a benefit in terms of cost as well, because from what I know from AWS, I guess there is a cost per policy evaluation. So if you manage to get some of the data back and the policy back locally and take local decision, it helps you to reduce the cost as well, or to manage the cost at least.
Yeah, absolutely. It does. And that was one of our strategies as well. And I know AVP now has some bulk endpoints where you can make bulk decisions, which is great. And then, locally too, you can use caching to your advantage, right? So if you just evaluated a policy and that none of the the policy hasn't changed, and none of the metadata related to the policy has changed, there's no reason to call AVP again to evaluate that decision. You can store it locally, right? And with the system that I mentioned, where we're aware, in our systems when policies change, we're aware when metadata changes, we can then decide when the cache is stale, and really go in advance and reevaluate that decision. And then the next time we get called from one of these services, we already have the answer, which is super low latency, right? So, yeah, we find that the flexibility of that really gives us the ability to capture a lot of these decisions.
It's always the balance of finding when to expire the cache or to empty the cache, and that's probably one of the most difficult things in IT. It's cache eviction policies, especially in distributed system where you have multiple cache at different places in your system. How long did it take to implement AVP and CDAR in the Twilio Flex application, roughly?
It was quick for us. I think at Twilio, we go through a good number of architecture reviews before we get into the state of implementation. So we had a really good understanding of what we're going to go and build. And then I think everything was really straightforward. I think there's a lot of great Terraform modules out there that work with AVP, so you can use Terraform to manage your policy stores and to manage all your policies and your policy templates. Right, so you can, if you're already using Terraform today, it's really easy to manage your policy store. The Building the metadata service, of course, was optional for us, but we chose to do that. So that was a bit more overhead, but I'd say we built it in such a generic way that it ended up being pretty quick as well. And then, we do have an authorization service, which is basically just a proxy to AVP, or it could be really a proxy to a local evaluation as well. And again, I think that was very straightforward as well. So we really only had a small group of engineers working on this, and we were able to deliver it very quickly and show results to our customers very quickly as well, which was really important.
And now that you're there, it apparently delivered on the value that you expect from it. How do you see the future of that solution? What are the things you're thinking about improving or changing in your current solution?
Yeah, good question. I think our solution is gaining a little popularity at Twilio here. I mentioned that we applied it to Twilio Flex, but I think, these type of authorization systems can really be used across the entire organization. So that's super exciting for us, is looking at the potential use cases of, lifting it up above Flex and applying it elsewhere in Twilio. And then, there's a lot of exciting AVP features coming up on the roadmap, I think, that we're excited about.
Thank you, Peter, for explaining the Twilio's journey into AVP and why you came down to that choice, how you implement it, and Edwards for explaining what is Amazon Verified Permission AVP. And Cedar, if you want to learn more, please scroll in your podcast application. You will have all the links there to get started. How to get started in 1 minute, Edward? Maybe if I'm a developer, I want to give it a try today. I go to the AWS console and choose AVP, Verified Permission.
Yeah, so if you want to go through that quick start experience, in the Amazon Verified Permissions console, there's that quick start option you can go with. Link your API gateway and link your OIDC provider. Super easy, quick start. If you want to learn more about the Cedar policy certification, the design patterns, check out cedarpolicy.com.
Thank you, Edward Edwardson, Security Solution Architect at AWS, and Peter Lavelle, Principal Software Engineer at Twilio. Thank you for having listened to this podcast episode until the end. Next week, we are going to talk about how to orchestrate and coordinate agents in the context of generative AI applications. So something really, really different from the subject today. But now, go build.